All right, so I would like you to make sure that you're copying everything down exactly as I have it. And I'm also going to be asking you questions as we go along. So I would like you to evaluate the function at f of 0, f of negative 2, and f of 3. Okay, so when you evaluated f of 0, you would basically go ahead and plug in 0 everywhere where there is an x, and we would get f of 0 is equal to 1/2. When you plugged in f of negative 2, you can see the algebra work there, but we get 15 over 0. And so I want you to make a note if you're already forgetting about whether or not it's 0 or undefined. Remember that it is okay if 0 is on top, and it's no if 0 is on the bottom, right? So you cannot divide by 0. And then if we go ahead and look at f of 3, you'll notice that you actually get 0 over 0. Now that's actually a different term than undefined, but for our purposes in this class, we're just going to be calling it undefined for right now. Now they want you to rewrite the function in factored form. So pause the video, make sure that you can factor that. And this is what you get when you factor f of x. Okay, so now it says, what do you notice about the results of 2 of the 3 function values above and the factored equation? So look at the 2 results from above, 2 out of the 3, and connect them to the factored equation. And so from here, this is what I noticed here. I noticed that f of negative 2 and f of 3 from above are the x values in the denominator that cause f of x to be undefined. Okay. All right, so here's the definition of the restricted values. All right, so in a rational function, a restricted value is an x value that makes the function undefined. So the only way to get something to be undefined in a rational function is the denominator would be 0. So you need to find the value of x that makes the denominator equal to 0, and then that is going to give us something that's undefined. Okay. All right, so here it's asking you where my purple sticky is. It says the graph at the of f of x is pictured at the right, and we are going to describe the graph at its 2 restricted values. So remember that it was restricted at x is equal to negative 2, and then x is equal to 3. And so those portions, if you look, x is equal to negative 2, x is equal to negative 2, that's a vertical asymptote. And then if you also notice that at x is equal to 3, we can see that that's a hole. But at both of those spots, that's where the function is discontinuous. Okay, meaning if you a continuity of a graph just simply implies if you were to take your finger or your pencil, you should be able to trace it without lifting up your pen from the paper or your finger. And I would have to lift up my finger or my pen at x equals negative 2 and also at 3. And now you can see the domain of the function, that it is all real numbers except where the function is discontinuous, all right, at those restricted values for x. All right, so now let's take a look at this page right here. It says, study the graphs of the 5 functions below. Clearly, one function is different from the other. Identify the function and state 5 ways that this function's graph is different from the other 3. And so I want you to pause the video and answer the question. All right, so here are the 5 things. Doesn't matter the order in which you posted them. Hopefully you were able to get at least maybe 3, maybe 4. But let's take a look. We can definitely see that h of x has 3 sections as opposed to everybody else having 2. H of x has 2 x-intercepts here and here. It has a middle section, right? The other guys do not. And that intersection actually goes through that horizontal asymptote. So I think there's a horizontal asymptote right here. And then h of x has no holes, where the other graphs have holes in their graphs. And h of x has 2 vertical asymptotes. So there's a vertical asymptote here, and there's also one there. All right, so now we are going to move to this kind of chart. And I'm going to zoom out just a little bit. One of the things that I did was on the graphs, I just recopied the graphs since we are supposed to look at these graphs and also the table. It says, over the next few lessons, we're going to learn how to develop the graphs of rational functions and understand the connections between the equations and the graphs. So we're going to first start off by finding the restricted values, excuse me, the domain, the x-intercepts, and the y-intercepts of the graphs. And so we are supposed to identify the following from, and it shouldn't be 287, it should just be the previous page, right? So that's the previous page. So I put that right here. I'm going to zoom out just a little bit more so you can see that. So these are the 4 graphs that we are completing the table on. So I would like you to answer the questions that pop up. I want you to first factor, and then you're going to identify the domain from the graph, set each non-canceling factor in the numerator equal to 0 and solve, finding out what the zeros are according to the graph, what is the value of the constant term, numerator over the denominator, and then what are the y-intercepts according to the graph. So answer those questions as they come up. All right, so let's take a look at what we should have had for f of x. So if we notice, I factored, and then I also identified the restrictions, right? X cannot be 0, x cannot be -6, and I tried to color code the domain of the graph. So -infinity to -6, -6 to 0, and then 0 to infinity. And then on the green, you will notice that those are the x-intercepts. So it says to set each non-canceling factor of the numerator. So in this case, my non-canceling one is going to be x minus 6. And I set that equal to 0. And then that becomes my x-intercept. And then what is the value of the constant? So again, the constants are the numbers without a term. So 36, and then there's like a 0 right here. So that is undefined. And then it says, well, hey, what's the coordinate of the y-intercept? So if we look at this graph right here, there is no y-intercept. So I put none. So let's go ahead and look at h of x and see if you can identify those things. All right, so on h of x, here's the factoring. I'm setting each of the denominators equal to 0 to find those restrictions, the domain, the color coding, and I would like you to, again, try this on your own. Here I want you to go ahead and answer the questions that follow. And then now I want you to make sure, if you have any questions on any part of this table, please make sure you ask at the end of the video. All right, so now, and then maybe it might get cleared up right now, but let's see. It says study the information you found in the table on the previous page to respond to the following questions. So the first question, from the equation of the rational function, how do you determine the restricted values? So I want you to answer that question. And then from the equation of the rational function, how do you determine the domain? From the equation of the rational function, how do you determine the zeros? And from the equation, how do you determine the y-intercept? So all of this is all about the equation. How are you able to determine those things? All right, let's take a look. All right, so the restricted values are just simply found by setting the denominator equal to 0 and solving. Make sure you put your answers in the form of x cannot equal and then whatever value that is, okay? All right, so the domain is always going to be all real numbers, right? So negative infinity to infinity, except the restricted values. Okay, so wherever the restricted values that you found here, you need to include those in the domain. All right, how do you determine the zeros of the graph? Well, you set the numerator equal to 0 and solve, but do not include the canceling factors. So the idea is to cancel out those factors and then set whatever non-canceling factors you have equal to 0 and solve. All right, and then here we have the y-intercept. It's just the ratio of the constant terms between the numerator and the denominator. All right, so we are to take this, these last 4 questions, rewrite the function in factored form, identify the restrictions, what are the zeros and the y-intercepts. So I'm going to have you do this and answer the questions. As soon as you're done answering the questions, we'll go over it. All right, so here we go. We've got this in factored form. You can see that the restrictions are going to be x cannot equal 3, x cannot equal -1. And so this is what it looks like in interval notation for your domain. The zeros of the function, you set those non-canceling. See, those are the canceling factors. So you set this non-canceling factor, 3x plus 2, equal to 0 and solve. And then the y-intercept is just going to be, if you go back to the original equation, it is just going to be the ratio, the division of those constants. All right, so try g of x. All right, let's see how you did. Here's the factored form. These are the restrictions. This is the domain. Again, the non-canceling factors. So if I were to cancel out x minus 2, I am left with x plus 5. That's going to give me my 0 of the function. And then the ratio here, -10/4, gives me that x-intercept.